Cool. So today I'm going to be going over basic stats in R. So I guess the first thing would be to open up RStudio. I haven't done so already. And did everybody keep like their project of last time? I guess not everybody was here last time. Okay, so I'll just go through step by step again. So if you do File, New Project, and then if you do New Directory or Existing Directory, actually, if you already have it, for some of you, you already have the project, I think, from last time. It might be in the list here. I can't find it for me, but yeah, the DNS one, yeah. And then New Directory, Empty Project, and then specify where you want it. I would say just put it on your desktop for now, and then type out the name that you want it. And then you just click Create Project. Now I already have one, I think, from last time, so that is, it's on my desktop. What was it? Actually, I don't even, I might have deleted it accidentally. Okay, so New Project, New Directory, Empty Project, DNS R. There we go. Okay, so first things first. Last time I kind of went over the layout of RStudio, and so I'm not going to do that this time. If you want like an introduction to RStudio and the layout of RStudio, if you go into Tools, or wait, no, Help. I always do this. Help, Cheat Sheets, and then RStudio IDE cheat sheet. There's a great cheat sheet on how to like what exactly is the RStudio and how to interact with it. So you can check it out there. But in the meantime, I am going to get you guys to open up a new file. So if you just do, I think it's Control-Shift-N. Yes, Control-Shift-N opens a new file. And then do save. Now, I want you to save it as like stats, but call it RMD. So at the very end, do .rmd, and then click save. And it'll say, oh, do you want to change it? And then you say yes. Because we're going to start using our Markdown. I'll try to consistently use our Markdown files. So that's what the RMD stands for, is our Markdown. So the first thing is so our Markdown is just a way of like interspersing code with text. And so it allows you to be able to generate documents with the code that's been generated, and it puts it directly into the text, into the document. So you can make like Word documents, HTML documents, PDF documents from our Markdown. So some things that I'm going to cover are the mean, standard deviation, correlation, ANOVA, and linear regression. Standard deviation, correlation, and ANOVA. So if you want to insert a code chunk, you do Control-Alt-I. So that inserts this code chunk right here. Control-Alt-I. And so now you can add code here that that you can then send to R. So any code that you have will be sent into the console, the R console here, and then it gets run. So in this case, I want you to do ps read.csv http/. code as manuscript.github.io/code along slash states data. I think that's right. It's not right. State data. Code as manuscript./code along/state data. Hold on, I can't remember if I. Oh, it's the right location. There you go. Sorry, that was the wrong one. So it should be http:/code as manuscript.org/state data/states data. There we go. That works now. So what that does is I have on my website some play data set that you can use. And so read.csv is just a way for you to import data from either a file or from like a URL and put it into R. So in this case, I've put it into the object ds. And so now if you want to see what the ds object looks like, you can go head ds. And do you remember what head does? Want to take a guess?
Header.
Yes, it's the top. It's the first 6 rows. So you can go, you can see that there's a state name, population, life expectancy, and so on. Okay, so we now know kind of what exists inside that data set. So if you want to see what the names, the column names of that data set are, you can do names, data set, and then it gives you a list of names here. Now, the very basic stats that you can use are like the mean, standard deviation, median. Now, each of those, if you look at the help file for it, if you do question mark mean, wait, that over here, question mark mean, just typing that out here on the console, and then press enter, it brings up a help for this particular function. And so it says here, it's finding the arithmetic mean, and then it says x. So that's the first argument. So everything, can you remember what I said last time about what there's like kind of like 2 things in R? Like that you can basically understand about it? That's okay, it was like 2 weeks ago. Everything that exists inside of R when you're working in R is considered an object. And everything that happens, like the action, is considered a function. So if you ever need help with any of those functions, so every function has arguments that you have to give it. So it's like, it's an action, but you have to tell it what type of action you want it to do, or to do it on. So it's kind of like a noun with a verb. So the verb is the action, and the arguments are the nouns. So you say, run in the city, walk downtown. Kind of this walking is the action, and then downtown is the object. And that's kind of the same thing here. Is like mean is the verb, to do it on X, which is the noun, the object. So
And X will be your first variable column.
yes. So I was just gonna get to that. Yeah. So it only allows vectors, which a DS right now is called a data frame. It's not a vector. A vector is just a series of either numbers or quotation marks, like character values, but it doesn't contain anything else. It's just a single thing of either numbers or characters. So because if we want to get the mean of something within the data set, we have to go mean ds $. And then the nice thing about RStudio is that it automatically allows you to choose some of the column names. So $, is just saying, okay, I want like, this is the action saying, okay, I know you want to use the data set object. You're trying to tell me to use population in this case. So you're saying specifically, I want to look at the population variable within the DS data frame. And then if you were to run that, let's do that again, you get the mean of the population. Now we can do the same thing with all the other things. So standard deviation would be population, and again, you can run it, and it gives you the standard deviation. Median, again, same thing. Let's change it up to like life expectancy. Do the same thing. There's also a IQR. Yeah, there it is. IQR, DS. IQR is just the interquartile range. So usually when you present median values, you also present the IQR because that's the interquartile range. So just like mean is often accompanied by the standard deviation, the median is often accompanied by the IQR. So that's the simple basic statistics, and that's how you extract values from them. If you want to format them, like let's say the median is has too many significant digits, so you can say I want to round that. So you say round to 2 decimal. Let's just go with 1 decimal place, and then that rounds it to 1 decimal place. So the nice thing about this is that you can say the median, so within the text, you can say with the median of life expectancy in the states data set is, you could do this backtick R, round, median, DS, life expectancy 1. Now what that does is when you knit this document, it'll put the median inside the text. So you don't have to copy and paste. It just cuts down on the amount of time that you have to do any sort of manual stuff. Because the point of learning R or any type of like programming language is for you to automate it. Do as little work as possible while getting as much stuff done as possible. You can't get the data set to work? Did you run it? No? So run this. Just like, yeah. Oh, control enter. Go back up. There we go. And then you need backticks. So not dots.
Oh.
Backtick is that.
But what does it do?
It's just a command. It's saying treat this as a range. So then save this. And then type out like sure .rmd. Yep, save. Yes. There we go. So now, if you just move this up there. Oh, you don't have it. There we go. So before I continue, is everybody at this stage? No. I'll let you. I'll take a moment here. You can copy and paste this stuff. It should end up looking. So if you do Control Shift K, it should look like. Oh, where is it? Viewer. It should look like this at the end. If you do Control Shift K. So I'll leave it here for right now. So one thing that two people did is those aren't dots; those are backticks. So if you want to like have a code chunk, do Control Alt I, and it automatically inserts a code chunk. So try that right now. So right above, just do Control Alt I. There we go. Okay. So these are dots, not. Yeah. So now you just move all of that.
You have to put these two feet inside. Here.
So these things, head and names, should go inside that page.
So it always should be inside.
Yes. So code should be inside the code chunk. So then here, you can get rid of this curly bracket or else curly bracket, but keep the backticks.
Okay, so it's
And
probably
then
zero.
get rid of those other backticks. And then this should be a backtick, and that should be a backtick. So go here, and then add it. Normally it's this. Yeah, there you go. Yeah, that's the one. Perfect, yeah. Got it? Awesome. So did everybody?
I think it's different.
Yeah, no problem. Let me see. So you can't run this line, but you can click this line, hit HTML.
How it does that.
Here's HTML. When you want to, like you don't have to use document, when you want to see what the document looks like, or like you're close to finishing the document, like for example, it's a manuscript or this is, you can write this up in this format, then do it from otherwise you can see. So I'm going to try to connect to this. So just type in the password. I think it's trying to download something or install a package. Did you try knitting it?
What?
Did you knit it?
Like,
Yeah, the little button. The top it says knit HTML. Okay.
oh yeah.
Yeah. So click that. Yes. Did you click it?
Of
Yes.
course, yes. It doesn't have to be.
So this has to be backtick. And then backtick at the end. So everybody's installing stuff. That's I thought I thought RStudio automatically came with those packages, but I guess it didn't. Which is too bad.
So even though I said mean and standard deviation in the console, I just get the mean standard deviation. Even though it's within the backtick bar. So I have mean standard deviation.
Yes.
But down here it's just mean.
Oh, because you didn't run it. But if you were to click knit,
I did click. Okay. Yeah.
oh, are you connected to? Oh, yeah. Oh, compilation failed. So type out R Markdown. Yeah. So, there we go. So now you can read this. So now it runs it. Yes. So if you actually get to the space here, because if you notice, it gives you a list. So there's no. I think I'm okay.
They already did it twice.
Did it work for you? No. Oh, it's still loading? You might have to, yeah, just shut it down and then try it again.
So do you have to run everything within your check bar boxes, or when you do knit, it doesn't?
It does it for you.
Okay.
Yeah. You don't have to do anything. That's the nice thing about it is like you just make a slight change and then rerun it and it just runs it from beginning to end.
The whole thing, not just with what's in.
Yeah, the whole document, whole file. Yeah, it worked. Good. For others, it's still. Did you try restarting the computer? Okay. There's always these types of problems that come up, especially like in the very beginning, when like your computer isn't all configured for it, and there's always like these things that slow stuff down. Do you get it? Yeah. The last one. And again, those things are backticks at the end there. So this is a backtick, not the comma, the quotation mark or whatever. So I'm just going to go ahead and hopefully it gets better for you. Okay, so I want you to add another code chunk. So Control-Alt-I inserts a code chunk. Let's just get rid of this for right now. Head. Okay. So the next one is correlation. So if you want to look at the correlation, you can do core. Now correlation is between two variables, continuous variables. So we have to give it two arguments, so two objects to be able to do the action on. So we'll do ds population, comma ds. Let's do life expectancy. And then if we run that, we get the correlation between population and life expectancy.
Do you have to state that we're working with DS every time? Or is there a way to?
There is a way. So there is a way so that you don't have to always type out DS. It's better if you don't. So if you always state DS, or what I'll eventually cover is like called data wrangling, and that uses dplyr, which is a package, and it makes it a little bit easier to do things like this without having to do like DS, whatever. But like that's another big topic in itself, so I don't want to cover it all right now. But this is the standard way of doing it. So that's the correlation. And then we're going to do something a little more complicated. So again, make another code chunk. We're going to do an ANOVA. Now let's see here. Names. Yes. Division. Okay. So I'm trying to remember on. Okay. Actually, I forgot to mention one more thing. So there's also, so you'll notice that the correlation doesn't give you anything like a p-value or anything. Now, generally, if your sample size is big enough, you don't really need a p-value for a correlation, because like you're going to get it even if it's like a small correlation. So in general, like for example, the data sets that I work with, you don't really need to have a p-value for the correlation, because one, the correlation is just exploratory, and so it doesn't really matter what the p-value is, and two, the population is big enough that the correlation will almost no matter what, give you a significant value. So, but no, this is the row, the correlation row. So it's Pearson correlation. But if you have a smaller data set, then you want to find out what the p-value is. So you do core.test and do, again, the same thing. Population, life expectancy, and you run that. And you get this whole like big output here. So it tells you, tells you it's the Pearson product moment correlation. It tells you some little tidbits of information about it. So the degrees of freedom is 48. P-value is not significant. It gives you confidence interval, and so on. I think generally when you run, I'm going to put it into an object here. So I'm just going to call it core with a capital. And then put that into it, the summary function. Okay, this one isn't really useful, so ignore that one. So this what it normally gives is like this kind of output here, which isn't really useful to be able to then work with later on. So like, for example, like let's say you wanted to insert the correlation and the p-value inside of text in like an inline. So you want to do it within your results. You want to state it. The way you do that is if you use a package called Broom. Did everybody install that beforehand? Okay. So I want you to load that package. And what Broom does is it just tidies up the output of most statistical tests. So if you do tidy and do core and run that, it gives you a data frame. So we can do I'll wait till everybody's done. Can everybody see that good? Well?
Currently, I didn't install.
You didn't install? Tisk, tisk, tisk. Did you run library Broom? So now if you do view, so view is just a way of looking at the contents of a data frame. So if you do view, put that in the tidy core and run that, you get a little image of this particular thing. So it's because it's now a data frame, you can access it more easily than before. So delete that view and put this into core 2. So now when you do core 2, you say, I want to look at the p-value, you can put that inside text. So you can say the correlation is R core 2 and it is not significant. P is equal to R core 2 p value. So now when you run, when you knit it, you can look at, and it shows you, it puts it right inside the text. This is the correlation and this is the significance. You can obviously format so it's rounded rather than be multiple digits, but you can, that's something that you can do on your own. So then it just cuts down again on the amount of copying and pasting you do. So that's how you do correlation. So in ANOVA, tidy just makes, tidy converts, so originally it looked like this.
Yeah.
And then tidy then converts it into this. That's the only difference. It just makes it easier for you to then access each values. So rather than, it gets kind of complicated. So it just makes it easier for you to use the output. That's it.
And I might have asked you this last time, but say I import a new data set, do I have to do library Broom again for that data set, or is it already in?
In the console, it's already in. So if you've run it already, then it should be inside there.
Say I start fresh with another data set, another console.
Then you just have to run that line again.
Okay, so I still have to do library Broom, but tidy is already in, so I'm in my packages, so I don't need to do Broom.
You still have to do Broom because Broom is just telling R where to look for Broom's functions.
Okay.
So like,
so I would have to do them all. So when you start
Yes.
a new thing, you do
Yes.
import your
precisely.
so
Yes.
slide, define, and all
Yes.
that right at the beginning.
Yes, exactly. It doesn't take too much work. If you just put it all inside of a single code chunk, then you can just do Control-Shift-Enter, and it runs everything in that code chunk. So it doesn't take too much work, and it's better that way because then, as I mentioned before, it's like you cook a meal, and then you clean the dishes afterwards. You don't cook a meal and then leave the dishes dirty. So then the next time you cook, you're going to use dirty dishes.
Right.
You want to have a clean slate every single time because it just makes it easier that way. But what a package is, just so everybody knows, just what a package is simply a collection of functions. So like anybody can make a package, and all it does is tell R, okay, I want you to look in this location for these functions. And so tidy, the function tidy, is inside the Broom package. If that makes a little bit of sense.
So do you have like a little handy list of all the ones that you would put in at the beginning that would be standard, like Broom would be standard, you would put in all the time.
Yes, and in fact, actually, a recently created package called, and you don't have to install this right now, but if you go to packages, install, it's called tidyverse. If you install that package, tidyverse, I'm not going to install it right now, but then at the very beginning of your code, you just do library tidyverse, and then you run that. It loads all the packages that you would normally use in like an analysis. So you'd load packages that are involved in like cleaning your data set. So dplyr. It loads packages involved in data visualization. So ggplot2. It loads Broom. It loads a whole ton of packages that you can use that all kind of encompass this concept of tidyverse. So you can look up the concept of tidyverse. It's actually a really interesting idea, because very few people think about it. Because yeah, just look it up. Look it up. Okay, so I'm going to get to ANOVAs. What does everybody do, by the way, in terms of stats? What type of stats does everybody do, or will they do? Like, yeah, what type of stats? In your lab, in your research. Yeah, in your own, then your regression.
Do you mean the test? I think yes. Logistic regression.
Logistic regression. Same.
Survival analysis.
Sample size calculation.
Which one?
Sample size calculations.
Sample size calculation. Oh, like power? Okay.
Tests.
T-tests. Oh yeah, the T-test. I guess I could show you T-test. Do you want me to show ANOVA? Okay, I'll show you ANOVA. So pushy. I'm just kidding. Okay, so ANOVA is a little bit different in that we're starting to get into a little bit more complicated stats. So correlation is fairly simple, but then you get into ANOVA and it starts to get a little more complicated, and then regression. So the way that you tell ANOVA how to analyze the data is a little bit different. So in this case, an ANOVA is a continuous variable with a factor variable. So a factor being like grouped, right? So you have male, female, other, or something like that. So in this case, we have population and division. Division is the factor variable. I think it is.
You don't do TS.
Yeah. STRDS. Factor. It is a factor. Okay, good.
How do you put that little thing?
Oh, yes. So I was just going to cover that. Yeah, sorry. This little squiggly thing is called a tilde. And the tilde is right beside the backtick for most of you. For you, I think it's in the corner. So like this little squiggly bracket. It should be like right below the escape button. If everybody has that. Does everybody have the squiggly button? Or an escape? Oh, yours is different too. All these different, okay.
Yeah,
Is this the backtick or is this the backtick?
Yes.
That's the backtick.
Yeah, I respect
No. Yeah, you interesting. I'm sure it's probably in one of the options. Yeah, tilde. So TILD. And yours? Yeah, you got it. Yeah. And is it Eva?
exactly, but I cannot connect to you.
Oh, you can't.
I use the first one, and it's not about not typing password real quick, but yeah. So maybe for the
Yeah, don't worry about tidy first right now. But at least you have the tilde, right? And then yours, I think it's in the right location. No, it's not. The tilde is there. So it's right above. So that's the tilde.
okay.
So you have to do, I think you have to do either shift or like,
Yeah. So,
yeah.
sorry.
Yes, you got it.
So I just have a question about this. Why is
So it's not working because it's inside wood chunk. So you have to get rid of this. Because it's just text, it's just plain text. You want to have it outside.
So if I have anything that should be inside, if it's only text outside.
Exactly. You got it.
So in the ANOVA, there's ANOVA in a bracket, and you put population.
Yes.
You use population word instead of doing DS. And then
I'm going to get to that. Yeah. So in order for R to know what you're talking about, you have to do data equals DS. So this little squiggly bracket in R is considered a formula. So it's kind of like saying population is equal to division. And it gets more specific once we get into linear regression. Did it work?
No.
No? Does Google help at all?
No.
You can always, I think, change the actual, yeah.
I'm just gonna try to find it. I have no way to do the. This.
Oh, yeah, there you go. Okay, I'm going to keep going on.
Yeah, that's fine.
So can you make a pretty table again? Like would you view ANOVA or not?
I'll get to that. So
here you don't have to put the S at the beginning.
So that's what I was going to say is, so because this once there's this little tilde inside this object, it's now considered a formula. So because it's considered a formula, formulas in R are kind of special. Like R was created by statisticians, so they had this type of like thinking in mind when they created these things. So a formula is just a way for you to say, this is what I want to be looking at. So it's the population by division, and so because it's a formula, you don't have to tell it where to look, but you do have to tell it which data set to use. So that's why you say data equals DS. So if you run that, you get this thing. It gives you the sum of squares, it gives you degrees of freedom, and so on. Now let's put it into an object. So I'm just going to call it ANOVA, caps matter. And then if you do summary ANOVA, it gives you a little bit different output than before. So it shows you the sum of squares, the mean squares, it tells you the F value, and then it tells you the probability. So it says that there's something different. There's a significant difference in population within division. Now again, this isn't that easy to use if you want to include it inside of your text, or if you want to like present the data in like the results section. So you can use tidy ANOVA and run that, and it does again the same thing. It converts it into a data frame so that you can extract specific values from it. So in this case, I'm going to put it into ANOVA 2. I'm going to say there is a significant difference in population between divisions. P is equal to, and then you can do R ANOVA 2 p-value. Now, because there's two, so if we were to type out here, let's see here, tidy. So if we were to go like this and do ANOV to p-value, oh, I haven't run it, sorry. Nope. ANOV to p-value and just run it like that, it gives you two values. That's because it has two rows. So in order for you to say, I just want the first one, you do ANOVA bracket 1, because I want the first value. It takes the first value from that string. So this should actually be.
You want both to appear in your table
Afterwards?
Yeah.
So if you want this as the table, what you can do is the table is below. And then you type out, now you're going to have to go library, or wait, no, let's do this. Knitter, : cable, and then type out ANOV2. Now, knitter is a package. When you do : it's saying, I want to extract the cable function from knitter. Now, everybody should have knitter already there because our Markdown relies on knitter. If you Control-Shift-K and then look at the bottom, it creates a table for you without having to do a whole lot of work. You can see how like this starts to save some time. If you change your data a little bit or you get new data, you just have to rerun your Markdown file and then the table is generated. No copy and paste. Yes.
For the one the one in Broom, did you just choose or
This one?
Yeah.
This one.
Yeah. Because I couldn't write, so I'm writing it myself, but nothing appeared.
When you did knit?
Like before, when I was typing it.
Oh, did you run this?
Yes.
So try it again. So make sure to do ANOV2 and then tidy ANOV and run that. And then try ANOV2. And if that doesn't work, let me know. Did it work? Do you want to check?
So what's the help? Oh yeah. It won't come up because it's inside text. Yeah, but I didn't. I had to type it out. Yeah, that's. So like you could do so. Yeah. And then to choose and then you can go back. So close off with the back tick. And then copy and paste that back. That one.
That's working for you.
And then add 2 colons. You have 1 colon, so it's just on that. There you go.
How's everybody else?
I'm connected.
Oh, now you're connected? Okay, I'm going to go to linear regression. So in linear regression, make another code chunk again. And so I'm going to show you I'll change this to G. So the main way of doing linear regression is using GLM, which stands for generalized linear model. And so if that's that's a function. And it's asking for formula and family, as well as the data. Well, it's asking for a lot of stuff here, but in this case, let's do like something like life expectancy, tilde, let's do income plus, or I'll start with this just for example. Data equals DS. Now, if we go and just look at GLM, look at the help for GLM. It asks for a thing called family. So in stats, a family would be considered like the type of distribution that you're thinking of looking at. So in this case, the family would be, because we have the outcome variable here, in the y position, is continuous, we would be looking at the family of the Gaussian. So it would be a Gaussian distribution, considered like normal. If it was a binary variable, for example, I don't have a binary variable here, but like let's pretend that this is sex or something. That would be considered a binomial distribution. So you'd put in family, so you'd say like family is equal to binomial. And then you just run that. But in this case, we want to use Gaussian. So we can run that. Shoot, that's wrong. Oh no, I didn't. Did I? Oh yeah, I did. Huh. GAU. And you run that. And again, you get like this bunch of information. Not really that, it's kind of hard to like use. So we'll put it inside of an object. I'm going to call it fit. And then you can do again, summary, fit. Oops. And it gives you back a little bit more information, actually a lot more information. It gives you back like residuals, it gives you back coefficients, significant coding, AIC, which is a measure of model fitness. But if you want, again, to use tidy, you can do fit, and that converts it into into a data frame. So if we take one step further and put it to, I'm going to call fit 2, and then again knitter cable fit 2. You get something back, a cable that you can then knit. So I'll wait a little bit, because then we can then add covariates to the model.
The equation is for the distribution of variables.
Yes, of the y. So this is, so if anybody knows, like, does anybody know the formula for regression? You should. Because not like that you should right now, I mean, or that you should have in the past, but it's something that's really useful to know, because if you break down the linear regression model, it essentially encompasses almost every single stat that you can think of. So if you understand the linear regression equation, you understand t-tests, you understand ANOVAs, you can understand logistic regressions, you can understand some of the stats that I'll be showing next in 2 weeks. And it just gives you a better sense of what's going on, because almost everything is revolved around linear regression. Even correlations. So the equation for linear regression is, so if inside our Markdown in the text section, if you want to type out equations, you can do these double quotation marks, double dollar signs, y is equal to x b plus e, dollar signs. If I run this, you'll see at the bottom that it gives an equation here, which is kind of nice. Very pretty, actually. Try to do that in Word. Good luck. Be there for 20 minutes. Did you run the fit line?
Yes.
So you have to put it into, okay, so you have to put GLM into, so type out here, type out here again on 42, just go to line 42, type out fit, and put it into that object. So alt lines. Or that. Yes, now run that. And then you can proceed. And then don't forget to put fit 2 inside of it. Yes. Okay.
Now, if you ever want to like take I've kind of written something. I've kind of written something. If you want to kind of look at how, where is it? At what I'm meaning by if you understand linear regression, I've written something up on the blog here. So you can just go to that and then see how, if you start breaking it down, how the linear regression can be used for almost everything. And so I include the formula as well as how you calculate it in R. And you can just break it down and see what it kind of looks like. I've even included plots to give a sense of what it looks like. So I'll put the code, I'll put the link along with the code that I'll then push to the website. So you can see at the website everything that we've gone through today. Just as a reminder, link. Okay. So linear regression has the formula of this. So depending on what distribution you use, so the family is dependent on what the y is. So if the y is continuous, then you'd use a Gaussian distribution. If the y is discrete or binary, then you'd use the binomial. If it's a count data, you'd use Poisson. And you can all specify that right here with like the family. So you can change it depending on the situation. But you can still keep the same formula. So that's kind of like the nice thing is you don't have to change anything with the formula, you just have to change the family or the distribution.
Can we do this
With which?
distribution with the dots,
Check the distribution.
the line?
Yes, you like have a regression line. Yes, you can. That will probably be covered next week because next week is visualization.
And what's the difference with this function, with the Gaussian function?
So the Gaussian function just tells generalized linear model what the y is. So we know that the y is a continuous variable because we know life expectancy is a continuous variable. So you say that you use the Gaussian distribution. So for you, because you were going to be doing logistic regression, which is binomial, which is a binary variable, so you'd use the binomial function. So it would be binomial.
Okay. It's an assumption.
Yeah, it's an assumption. Yeah, exactly. That's a good way of saying it.
We have that one.
I don't know if it works without the bracket. Does it work? You can do it either way because Gaussian is also because it's a function. If you put it as brackets, it does the same thing as like leaving it out.
Can you show us the blog then?
Sorry?
The web page to your blog.
Oh, I'll put it up.
Okay.
So I'll have it on the website. But I'll put it up right now. So it's luke.wjohnston.com/variance linear regression. Oops. So now if you want to add covariates, it's fairly simple. So I'm just going to copy and paste this section and put it down here. Are you okay? I'm going to call it fit3 or fit covar. Fit covar. Covar. Now so if you look at the equation is x, and adding a covariate would be as simple as doing, oops. So this would be x1 plus x2 plus and so on. It's the same thing here. You just do plus frost, let's say, or life population. So we now include within the model population. And you can keep on adding variables however you want. I mean, it's better to be minimal than to go over. If you were to run this, it, you'd get, so before it only showed income, but now it shows population as well. Does anybody have any questions? Does it work?
Yeah.
Yeah. So I think that's like about it for now. I covered what I wanted to cover. It's the basics.
How do you change the headers of the table?
Of this table. So if you wanted, you can. Okay, well, I'm going to show you. It's not too complicated, but it's easier if you use another package. So I'm going to use another package here to show how it's done. And then, so fit cover do pipe select. I want to just estimate. So estimate data equals estimate. P is equal to value. And term. Variable is equal to term. And you pipe. And you emitter table on that. So select is just a function within dplyr that tells you, that says, I want to choose term, estimate, and p-value from this data set. And you want to rename it to variable, beta, and p. So this is the new equals old. New, old, new, old. Now this is starting to get into like using dplyr. You can do, I think I showed some of you last time, like some really cool stuff that really makes it easier for you to like to plot graphs, to make tables, to analyze your data, and it saves a lot of time knowing how to use it. And this dplyr is part of the tidyverse package that I mentioned before.
So why did you have to put it in the library?
Because I didn't do tidyverse. I just showed it. I didn't actually run it. Because tidyverse also loads in a lot of other packages that I don't want to show it right now. So that's it.